Hello, everyone, and thank you for joining us today for the Fronius Gen24 Technical Training Webinar. Just a few quick items before we get going today for any newcomers. During the webinar, all attendees will be muted for best audio quality. If you have any questions throughout the presentation, please use the Q&A button at the bottom of your screen to type in your questions. They will be monitored and answered at the end of the presentation. This webinar will be recorded and shared with all of you within 1 week of today's session. And it is my pleasure to welcome back Fronius presenters Harsha Kumar and John Austin. Harsha is the manager of tech support at Fronius and has been so for the past 7 years. He has a background in power electronics, power systems, and renewable energy. John is the director of sales at Fronius Canada and has a background in commercial roofing and manufacturing sales. Without further ado, I will pass it over to John to get us started.
Thanks so much, Tatum. And for all of those that are attending the webinar today, I thank you for your time. As I said a couple of days ago with our sales presentation, we certainly understand how busy all of you are, especially this time of year. So anytime that Fronius can have of yours to go through a new product like we will be today is most appreciated. So thanks for taking the time. And a bit of a disclaimer for those that attended the sales presentation of a couple of days ago. This presentation is virtually the same presentation, with the big difference being you're only going to hear my babble for the first 2 slides, and then I'll be handing it over to Harsha, who will go much deeper into the technical component of each subsequent slide following. So without further ado, we will jump in. We're here today to talk about the Gen24 and our launch of the Gen24. So we are going to start with our roadshow map. At the start of August, we start on the East Coast and we work our way across Canada, introducing the Gen24 at venues, again, across the country on the dates listed. For anybody on the call that's looking for additional details on our roadshow dates, where we are, the exact timing of the day that they're going to be on, etc., please look at Fronius Canada's LinkedIn post. Or at the very end of this presentation, I will have my contact information up. Don't hesitate to reach out to myself to get more details. We would love to see as many of you out there as possible. There's a registration link that we can provide you with. And then after our roadshow event, we'll all be heading to a restaurant/bar for a little bit of an event after each occurrence. So again, what you're going to see a lot of from Fronius is a constant campaign, and the Gen24 inverter that we're about to show you is it dovetails very nicely into our 24 hours of sun campaign. And if we have to boil down our 24 hours of sun program, it is a sustained effort by Fronius to move away from fossil fuel generated energy and harvesting as much of the energy as we can of the sun to facilitate or at least address most of the household loads that come up. And we want to do that over a 24-hour span. So grid tie inverters only work when the sun is shining and we're sending it back to the grid. Hybrid inverter that we're going to talk, or at least a hybrid ready inverter that we're going to talk about today, will allow us the battery storage component. This is a very, very busy slide, and I appreciate that. But as you drill down into each of those points, in a nutshell, what we're saying is if you look at our European product offering, we have many more products to offer the market, and we are right now in the process of introducing more and more of these products to the North American market. So today is a Gen24 discussion. We're going to touch on the fact that the full hybrid version of the Gen24, the Gen24 Plus, will be launched at the end of this year. We've got a 3-phase solution coming up next year for the current SIMOs that you're familiar with. And then we've got other products like e-mobility up to and including hot water, the ohm pilot. So again, by introducing a hybrid ready inverter in the Gen24, it gives us that battery storage capability, and that will allow you to manage your energy needs much better, even when the sun isn't shining. So without me babbling, I promised I would only talk for a couple of slides, and I'll stick to that. Harsha, I'll turn it over to you, sir.
Thank you, John. Thanks, Jaden, for the introduction. So what we are talking today is about the Gen24 with a little more emphasis on the technical side of it. And so what the Gen24 is, it is a string inverter, just like you would have seen if you've used Fronius in the past. You would have seen the primos and the simos. The Gen24 is exclusively a single phase unit, and it's basically the next version, if you will, of the single phase string inverters. Okay. Now, when you do buy the hardware, it comes ready in the sense that it's already got the hardware to make the same device hybrid inverter capable of working with storage. The only difference being when you buy it off, ready, from us or from your distributor, it comes as a string inverter. And when you are ready to make it, what should I say, or you want to invest in storage and make it a hybrid version, you would pay for a software upgrade, which would, once you download and install the software onto the same device, it is now a hybrid inverter. So that way, you're not going to have to redo any additional wiring or change out the machine or any sort of thing like that. The only other thing would be you would need to have some sort of an interface, because if you do have a hybrid system with storage and you have an outage, you are not going to be permitted to be connected to the utility or hydro because you have the chance of the risk of backfeeding into the grid, which isn't permitted. So for that, there is something called a battery backup box. Okay, and so that would be the additional thing that you would buy, but that would not change anything on the inverter side of the business. It's going to be between the inverter and hydro or the utility side of it. So that's something that you want to keep in mind. Now, in terms of the, all the benefits that we do have from the existing simos and the primos, the same will carry over into this. If any, it actually, there's a few additional benefits, which I will talk about a little further down. Okay, John, could we go to the next one, please? Okay, so now the inverter itself is the heart of the PV system. Okay, and everything else is basically a kind of, what should I say, either feeds into the inverter or the inverter feeds into your AC panel board. Now, in terms of, design simplification, it's still going to be a string inverter. It works at a maximum DC input voltage of 600 volts DC. And on the AC side, you can have it on a single phase system, which is either going to be one leg of a 3-phase 208 system, which is why you will always see that from these single phase inverters will have the terminology Fronius whatever 208/240, which means the 208 is you can use it on one leg of a 208 3-phase system, or you can use it as a 240 system, which is between legs. Okay. Now, in terms of the design itself, it's got the advanced maximum power point tracking algorithm. We call it the dynamic peak manager. The oversizing ratio, as always with any Fronius product, is 1.5, which means that if the inverter's rated AC capacity is 10K, you can throw 15K's worth of solar panels on this device, as long as you keep the voltage and the current within the device's limits. So we do have a tool, a free tool. It's a web-based tool. We call that the creator tool. So anytime you want to, come up with your design, you can throw your idea onto the tool. We'll walk you through how to use that tool as well. Okay, and so that gives you what would best work with this thing. It actually doesn't give you just one, it gives you many options. And depending on what constraints you've got on your roof, you can use that to your advantage there. The device itself comes with 2 MPPTs and different power classes. So the power classes range from 3.8 all the way up to 10. The physical frame size is the same for the power classes 3.8, 5, and 6. The physical frame size is the same for the power classes 7.7 and 10, but there is a difference between the small and the big power classes in terms of their physical footprint. On the DC side, like I mentioned earlier, they are all only operable up to a maximum of 600 volts DC. And on the AC side, you can work them off of a 208 or a 240 connection. They still come with 2 MPP trackers, and you can have 2 connections per MPP tracker as opposed to 3 in the older models. But those models also went up to 10 and 15K. These we are working on getting higher power classes, but I don't yet have any definite dates or answers on when and how they would be made available, but we are working on that. That's for the single phase. Now, in terms of the product strengths itself, John, you want to bring up the bullets? Oh, I'm sorry. Can you come? Yeah. So our biggest product strength is actually the support that we are able to offer, because outside of your support and your service infrastructure, everything is just hardware. And that's not just true for Fronius, but for every other manufacturer. It's hardware, and it comes with a price tag. How are you able to support said hardware, and how good are you at it is what defines us. So we will make sure that we're always here to support you. And so how we support you is in different ways. It could be through in-person or through any of our self-help tools. But in either case, you always will have somebody to reach out to, because we are based out of Canada as well. Now, in terms of installation, if you have installed Fronius inverters in the past, you're very familiar with what is called the snap design, because for the snap inverter design, the idea was to have minimum effort and time when it comes to wiring or changing out things. So the same idea has been carried over here into this design as well. So what you are seeing here on the left side, you've got those orange terminal blocks with your positive wires coming from the PV array going into one block, your negative black wires going into the other block. So those blocks themselves are not screw terminals. You can see that they're a catch release design from Molex, the accessory manufacturer. And if you wiggle the block comes loose completely from that receiving end of it. And so were you to require an exchange for whatever reason, all you had to do, or all you're required to do, is to wiggle those blocks free. It comes loose, so you're not undoing and redoing wires. The same applies for the AC side. And should you already have it battery ready and you've got the battery wired in, the same concept of catch release and wiggle the block, it releases all of your wiring from the inverter. Then you swing the inverter off the back plate, and that's it. If you want to exchange it, you put the new one in, you reintroduce the wire, the terminal blocks, and then you wiggle it in, and you've made the connections there. So it's as simple as that. In addition to this, we've had a lot of issues in the past because power tool use is not permitted on any Fronius equipment, not even to undo and loosen screws should you be using power tools. But despite extensive what should I say, push from our side, and all sorts of marks and notifications on any sort of material and documentation in the box with labeling on the inverter too, we still had issues where people would use power tools because they assume it saves them time, but that causes other issues, which is why we've completely done away with the screws anymore. So what we now have is basically what we call twist lock nuts. So you give it a half turn in the clockwise direction, you basically secured the fastener. You give it a half turn in the counterclockwise direction, you basically undone your connection. So it's as simple as that. And so you don't even need to use a power tool or anything like that. And because here is only one half turn, there's no question of you saving time via the use of a power tool. And yeah, now in terms of support and tools, we've got several different ways with which we can support you. So you can see that we are here in person as well to support you. You can always contact us either through email or you can give us a ring, assuming it's on working days. Outside of that, support does go beyond just talking to a person. So you also should understand that anytime you are stringing or panels for an inverter, the inverter's limitations need to be kept in mind in addition to any other site constraints you might have. Now, it's fairly common for most people to go through and use a third-party simulation tool, and that gives you a certain output. But that tool is very, what should I say, it's completely blind to whatever device limitations the manufacturer's device might have. So which is why, as a sanity check, anytime you get output for string design from a third-party simulation tool, you want to run those numbers into the manufacturer's own tool, which for us is called the Fronius Solar Creator. So that way you are ensuring that there are things that might be, limiting features on the product, which that third-party tool might have completely missed. And so you want to keep those things in mind. So what we'll do now is to give you like a dry run through the Creator tool. John, could you please take us there? So this is the actual Creator tool. Okay, now if you have used SolarWeb, our monitoring platform in the past, you can log in. If not, you can continue as a guest. Now, while you're logging in, because we are Fronius employees, we've got a separate login, and so that's where we would sign in. If not, you would say, you would use your SolarWeb sign-in, or you could even choose to continue as a guest. Now here, when you come in, we want to go to the quick PV design. And let's say we want to go with Canadian Solar. So if we start typing, it'll filter the list down, and so we get to pick from there. Yep. And then which model, just to keep it simple, we choose the first one there. Okay, so that's a Behiku, which is a bifacial. Now, if you do know what the bifacial expected gain is, I would always tend to overestimate the gain rather than underestimate the gain. For now, let's assume that we do not have any bifacial gain because it's flush mounted on a roof. Where it says the number of PV modules, you leave it beyond 0. The module temperature minimum and maximum is, although it says module temperature, ideally what you want to be plugging in there, and definitely more so on the minimum than the maximum side, is the lowest temperature you would expect to see at the site over the course of the next 10 or 20 years. So let's assume we are in Calgary and I'm going to say, let's go to -40. Okay, then we want to fix the country to Canada. Here it's already Canada, so it didn't matter. Then the series says all inverters and the type you want to pick, what model of inverter you want to choose. And since we are talking about the Primo Gen24s, we've chosen the Primo Gen24 10 for a 240. You can also choose it for a 208, but this is a string design tool, which is exclusively DC. So 208 or 240 on the AC side wouldn't make a difference. So we'll choose that here, okay? Now, the one important factor you always want to keep in mind when you are designing strings for a string inverter is that maximum oversize, which I was just telling you earlier about. So here, the default set on this is 120, but we will change that to 150 because you always want to go as big as possible on the PV array, simply because PV panels are always dropping in price. And that's the component that is least likely to fail. So instead of you throwing on optimizers or et cetera, whatever, to get more out of the same PV array, you might as well just oversize the PV array to the maximum permitted value by the manufacturer. Or John, you want to select the entire field and say 150 at one go. Otherwise, it won't let you load. Start typing Canadian, because sometimes what it does is it's a little laggy.
Sorry, Harshay, it's hung up.
Oh, just refresh the page. It'll take you back. Okay, and we want to fix the temperature to -40. Okay. Now, once you plug all of these numbers in there, based off of what you plugged in there, if you come further down this page, there's a table. That table recalculates every time you change something, in those fields up there. So here you can see that the first row, you've got the number in bold in the top left corner. That is the number of PV panels or PV modules that is suggested for that design. And there's different ways you can string up PV panels or PV modules in series for strings, and that many strings, it could be of the same length or different lengths, which if added up will give you the number in bold. So for now, like I mentioned, you always want to go with the maximum possible. But again, if you've got constraints on the roof which limit how many PV modules you could potentially work with, you want to stick to that number as well. So for now, let's assume you've got no constraint. So we will go to the right. Or if you click on the arrow beside the one to the right, it'll take you to the max, to the end of that table. Okay, so here the max possible is 21 PV modules, which works up to a PV array capacity of 14.81 kilowatts peak, based off of the type and make of PV module we've chosen. And if you look down that column, there's different ways you can string up PV panels which add up to that number in bold. Now, typically when you are choosing designs for for strings, you always want to go with the longest strings, as in the most number of PV modules in series, because shorter strings, especially if you look at one of the other options on this table on the left side, it does also give you options of 4 PV modules, 3 even. Okay. Now it might look, like it just adds up to the same number, but strings are best operated with more PV panels on them than less, because the MPP voltage of that string is a function of temperature, and which is why we want to make sure that you choose the lowest side temperature, not the average low, but the actual low, simply because that voltage, the open circuit voltage of the string, is a function of temperature. And the colder it gets, the higher the voltage goes, and the hotter it gets, the lower the voltage drops. So in summer, when you are working at the peak of summer, your air temperature might be, John, sorry, we can see your screen on the, yeah, thank you. So the air temperature might be 25 C, but it is possible that the panel temperature is way higher than that. Okay, so if you go very short on your strings, you might get hot enough that the MPP voltage might fall outside of that operating range. So you always want to keep that in mind. So for example, here, if you want to go with the option, you remember I told you do not want to go with small strings. The lowest string length for that option of 21 PV modules array size is 1 string of 3 on MPP tracker 2. If you see the last cell on the bottom on the right side on the column. Yeah. So John, can I have you click on that, please? Okay, so this is basically your string design. So it tells you that on MPP tracker 1, you've got options of 2 strings of 9 PV modules each. Okay, and if you come further down, you'll say on MPP tracker 2, you've got 1 string of 3 PV modules each. And now look at what happens to the open circuit voltage when the temperature is at 70 C. It's at 128 volts. So operating a string of 3 PV panels at that temperature brings it down at 128 volts, which is not something you should aim to do, simply because panel efficiency is very low at lower voltages. And also, it's not always the best of designs. So if you've got options, which will help you avoid having that short string, that shorter string, you always want to go with that option. So if we, for example, choose to go with the option where it says you've got, John, could we go back to the second option from the top? Yeah, the 7. Thank you. So here you see that this suggested design is actually 3 strings of 7 each, with 2 strings of 7 on MPP tracker 1 and 1 string of 7 on MPP tracker 2. And so here you can see that the open circuit voltage at 70 C is close to 300 volts. This is a much more preferable solution than the other one, but in terms of the array capacity, it's still the same array. Whereas this will give you way better performance and behavior than the other one. So little things like these will make a big difference. It's not very obvious unless you're actually, you've been in the business for quite some time and have strung up different PV modules or played with such calculators from different manufacturers or with different third-party design tools. So always aim for the longest of strings, not the shortest of strings, simply because you've got a little corner where you can shoehorn 2 or 3 panels there. Doesn't exactly mean that it will give you the same sort of behavior or performance, just merely because you've got the same count of PV panels. So that does make a big difference. Okay, John, could we go back? Yeah. Okay, the other thing is to commission this inverter, if you did, if you were looking at the pictures of this PV inverter, you'll see that it's got no display. Okay, so the way you would commission or look or operate or change settings on this model of inverter is we've got a light sensor in the middle, and if you hold your finger there for just a brief second or so, you will activate the inverter's Wi-Fi access point. So if you walked with the old primers and the SIMOs, you know how you can go through the display and activate the Wi-Fi access point on the inverter. The same concept holds here, except there is no display, except we've got a light sensor. So you hold your finger against the light sensor for a second, it activates the Wi-Fi access point, you connect to it with your smartphone, there's a web user interface, you can go through the web UI if you choose to, or you could use the Fronius SolarStart app. Okay, so you have to make sure that you use either of these 2 systems, okay? And the configuration or the commissioning is very straightforward. There's a wizard, and again, you can use either of those 2. Now, in terms of monitoring, again, there's no display here, so you always want to choose to go with monitoring. And a lot of people have the assumption that monitoring is just fancy bells and whistles. It is. It's more than that. Monitoring is also a health monitor for your system. It lets you know what's going on with the system, and it will alert you via an email if there were to be something that is concerning. Okay, could we go next, please? Yeah, now the last one there, sorry, is the Solar SOS, but we'll talk about that a little later. This is the commissioning app that I told you about. It's free again. You can download it on either the either App.storage, but for both platforms. And it's just very straightforward. There's no sign-in as such. You could skip even signing in, and you could just commission it there. Okay, could we go next? Yeah. Now, the monitoring is, very important. This is what I was trying to tell you about. So the monitoring platform itself is free. Okay, we do not charge for the monitoring as long as you've got your own internet. Okay, and in terms of the internet, you always want to make sure that your Wi-Fi is 2.4 gigahertz, not a 5 gigahertz, because this device will not see or connect to a 5 gigahertz Wi-Fi network. John, could we go to the demo for the SolarWeb? Thank you. So here, if you've used it before, you already know how it works. If you haven't, then we can show you the demonstration. I'll just show you, take you to one of our this thing. Can we go to the view demo option? I want to show them that Fronius one with the smart meter. So these are all different Fronius systems on different Fronius offices across the world. So what we'll do is we'll show you the one in San Luis Obispo in California, or the one in Hawaii, simply because these are the ones that we have, which would be producing now, because the remaining systems are all in Europe, which is pretty much done for the day. And so the sun's down. So here you can see that this particular system does have a smart meter, but for whatever reason, I can't see the smart meter yet. Now, if you do have this, then John, could we go to service messages, please? On the top. Yeah. So here's where, if you do have any issues with your system, you will get notified here. And there is a place where you can put in an email address. So that way, if the system were to experience any issues, it will notify you through that. So monitoring, again, most people have the misconception that it's a show and tell for your neighborhood or homeowners association. It's more than that. So monitoring is also a health monitor for your system. It's live, it's constant, it's always looking at your system. Should your system experience any issues, then it'll notify you here. And you can even go back in time to look at it. Like, for example, the default setting on this is the last 7 days. So you got that date range. If you click on the date range, there, it'll drop it down. Here you can choose to go however far back you want to go in time. So let's say you want to look at Jan to June. Okay, so the system was perfectly installed. It's got absolutely no issues. Some systems, depending on how old they are or how much, maybe you had some issues, maybe there was something going on. All of that will be, available here. Okay, but the condition is that you need to have your own internet connection, and the connection needs to be live. Okay, because if you don't have a connection and the inverter did generate a flag, then it's got no way of letting you know, unless you decide to go by the inverter, activate the light sensor on it, connect your device to it, and then notice it, which again is not likely something most people would be inclined to do. Now, the most common notification for this particular system is that it lost its internet connection. Okay, you always want to remember that should you change the password on your internet connection or your Wi-Fi, that is, or your service provider, the device has no way of divining what your new password is. You need to go into the device and update the new password. Okay, and if we go back to the actual main page of production, so here now the smart meter showed up. Now this is something that I really wanted for you guys to see, because monitoring can be of two kinds, with or without a smart meter. Given that this is a hybrid capable inverter, if you do have a smart meter, your smart meter tracks not just what the inverter is making you, it also tracks what else is going on in the house in terms of consumption. It won't give you a disaggregated view of what's being consumed, but it will tell you at your AC panel board that's feeding the house how much energy is being made by your solar, how much is coming off of hydro if you are running short, or how much is being sent back to hydro if you're overproducing. So that is basically tracked all the time. So here you can see that from midnight, they've been consuming about 1.7 kilowatt hours, but they basically started producing a little more towards dawn, but then it looks like their air conditioning load is fairly high in Hawaii, given the humidity and heat. So they are basically still buying from hydro. Now, this bidirectional log of energy consumption can be used to size your battery when you decide to upgrade your system to make it a hybrid system. So that's where the value of the smart meter is. So you can install the inverter now with just a smart meter on your AC panel board. So that gives you a log of how your energy consumption behavior is. And that behavior and that log of energy consumption can then be used to design your storage when the time comes. Okay, John, could we go back to the presentation? Yeah, thank you. So again, so you can also perform remote software or firmware updates on your device. Okay, you get to see what's going on there. You get notified should there be issues. And in terms of the oh no, let's go to the next one. Now, in terms of the device itself, the device is actually very simple, simply because it's only got 2 printed circuit boards. So you got a fan in the front, there's a big printed circuit board behind it, which is a power stage, and then there's the pilot. Now, previously, if you have worked with the primers and the simers, we had the concept of data manager, and you could buy the inverter with or without a data manager. That no longer is applicable here, simply because there is no data manager. Every device will have its own pilot. That pilot is already capable of connecting to whatever kind of monitoring you want to go with. Okay, so when it does come to exchanges or changing things out, the same idea holds. You don't really need to undo and redo your connections because it's a plug and play solution. So you would basically unplug those terminal blocks that I showed you about, told you about earlier. You'd swing out the power stage, as it's called, pop in the new power stage or the replacement power stage. You reinsert those terminal blocks, and you're good to go. Okay, so it's really easy to change around or replace should the need arise. Now, and also you've already kind of got an idea of the connection area. There's really not much to do there. Now, in terms of future-proofness for this device, I told you that the hardware is already hybrid capable. But when you buy it, you're not really buying it as a hybrid capable inverter, although the hardware is there. When the time's ready and you're willing to invest to make it a hybrid capable inverter with storage, then you would pay for a software upgrade. That software upgrade will convert the same device into a hybrid inverter, but you will still need to purchase the battery, We are working on options, different options, but for now, the option that is available is the BYD battery. Now, one thing that you do want to be aware, this is about, what should I say, upselling that idea of making it hybrid capable. So when you are ready, you basically, we have what is called the web shop. We don't yet have it launched, okay? But when it is launched, then you would basically go there, pay for the upgrade, and download the software file into your device and make it a hybrid capable network. Okay, now in terms of shade management, this is alluding to the peak manager or the MPPT algorithm I told you earlier about. So shadows or shade management is completely, what should I say, blown out of proportion and also completely mismanaged, if you will, from a what should I say, from a microinverter or an optimizer perspective. So one thing you have to keep in mind is shade can be of different types. You can have hard shade or soft shade. Hard shade is basically no lights getting through. So irrespective of whether you're having an optimizer or a microinverter, it's not like they can, what should I say, let through light through whatever object that is preventing you from, making any energy because you've got the shadow of a building or a church spire or a smokestack or something like that. So irrespective of what sort of electronics you use, that electronic device or appliance isn't going to get let light through that building or whatever it is. What it does is it helps minimize the amount of loss that could be encountered because of shading. And how do you minimize that loss? There's different ways of attacking that problem. Or one of the best ways to do is to make sure that you design your strings such that were you to have shading, you would be minimally affected by that. That's one way to do it. The other way to do it is to basically make sure that you choose the right algorithm, which is where this comes pre-built into the inverter. There's nothing you need to do. Okay. And the third thing is to make sure that you understand how shading works. Right. So for example, if I've got like a 2-story house next to a building that's like, I don't know, 40 stories, irrespective of what electronics I use, you're always going to have a problem. Okay, but if you've got shading issues, maybe due to trees and rustling leaves and vegetation, things like that, then there's different ways to attack that problem. So what you would do is to basically make sure that you understand how oversizing works in your favor. So that's also one of the reasons why we always push for you to make sure that you oversize to the maximum limit permitted by the manufacturer, which for us again is 150% or 1.5 times the inverter's rated AC output capacity. Okay, so in addition to that, this is the other kind of shade which is most commonly encountered. So here, this is, you've got a little projection on the roof. And so assuming that this roof is facing true south, you will see that the shadows cast till noon would be on a portion of the array on the west side, and post noon, it will be on a portion of the array on the east side. And so the dynamic peak manager on the inverter is tuned to make sure that you do not stand to lose a lot of power, in addition to all of the other options that are built into the solar PV modules themselves. So every solar PV module on the market will have bypass diodes. So just because you've got a little bit of shading on one portion of the array does not mean you've lost the production from the entire array, which is a common sales pitch that is used by microinverter manufacturers or by optimizer makers to kind of pitch their product. But you have to always keep in mind that the roof is the harshest place for electronics. And all of the microinverters and optimizers have to go on the roof underneath the PV module. And we just told you how the PV modules can touch temperatures of 70 C or even higher, depending on what your ambient temperature is. And that is kind of unavoidable simply because the amount of clearance you've got underneath the PV modules from the roof is limited. Because if you give too much clearance, it keeps the PV modules cooler, but then you've got the wind load on the PV array, which basically means that your PV array is now going to act like a sail. You don't want your roof sailing away, do you? Now, if you keep it too close, you basically reduce the amount of air circulation, which traps the heat and it builds up the heat. So now if I throw in more and more electronics there, then that's not exactly the most optimal condition where you should be operating electronics. And electronics will fail. It's not a question of will they, it's more a question of when will they fail. And you will also notice that it's not exactly easy to get to those places simply because of the way the array is built. Now, for example, if you were to have a failure in the middle of the array somewhere because you had an optimizer that failed on you, then you literally have to take apart a few panels from the edges to just get to that place. So that's a lot of work, that's a lot of time, that's a lot of money as well. And there is no guarantee that you will have these optimizers or macro inverters fail at the same time because they're basically designed not to fail. But when they do fail, they don't necessarily fail all at the same time. So I might have one fail today, I might have one fail in 3 years from now, somewhere in a hard to reach place. All of that is adding to the failure rate, which is why I was telling you that the optimizer or the microinverter's job is to minimize the loss of production due to shading, whereas they have a higher failure rate than the PV modules themselves. So another way around that is you've got the dynamic peak manager. Most string inverter manufacturers have very good algorithms, just like ours. So oversize the PV array. So that way you know that you've got a 10K inverter. The 10K inverter can only give you 10K despite having 15K's worth of panels connected to it. And you might ask me, why am I exactly oversizing the PV array? Because I know I'm going to clip. You've got to remember that the structure is fixed. It's not moving with the sun, whereas the sun, given how far away we are from the equator, can have quite a big range of angles and orientations that it goes through over the day, over the seasons. So now the light or the PV array, the light hitting the PV array, that is, only gives you what it's rated for, were the light to be hitting the PV array at 90 degrees or at right angles. But if you actually want to meet that requirement, then it's going to be very hard, because that requirement can only be met by a tracker, given that the sun's always moving across the horizon and the sky. So now, given that these are residential rooftops or whatever other structures which need not necessarily be trackers always, that angle is not under your control, which means that there could be very short durations of time during the yard during which you might actually be potentially capable of making the full power from the PV array or what it's rated to produce you. But that is not always the case. So then, depending on your clouds, your shading, your soiling, how high or low the sun is in the horizon, you will have different maximum power points. So that is MPP for short here. And MPP is always going to be moving across, the PV array, or the plot for the PV array, the IV curve, depending on the angle at which the light hits it and other issues like shading. So if you had absolutely no shading, then we're going to have the blue curve that you see here, which is called the global maximum power point. If you do have shading, then depending on how severe the shading is and what patterns that shading casts on the PV array, you can have multiple different LMPPs, which are local maximum power points. And the inverter's algorithm's job is to sweep across these curves, find out all the different local maximum power points, and settle on the best among them, best being the one that gives you the most power, and call that the global maximum power point for a certain period of time. Because by that, let's assume 5 minutes from now, the sun's moved again, and so the angle is different, so the inverter's got to sweep the curve again. And there is a periodicity to this sweeping business that the inverter does. And so that sweep frequency, as it's called, is different for different manufacturers. So ours, there's an example, it could be 5 or 10 or 15 minutes. So every 5, 10 or 15 minutes, the inverter will sweep across the PV array curve, the RB curve, find out which of the local maximum power points offers the most power, settle on it, and designate that as the global maximum power point for the next 5 minutes, and then sweep the curve again. So this is what the MPP algorithm does, and or our dynamic peak manager algorithm does. Now, there are times when microinverters or optimizers will outperform any string inverter on the market. That would be when your PV array is buried under snow. But do you really expect for your PV array to be buried under snow for 6 months of the year? Then you might have to think of other options than solar. Now, in addition to all of those features, now the inverter also does come pre-loaded, if you will, with what we call PV point. Okay, so even without storage, even without battery, were you to have an outage, there is a separate terminal on the inverter. It is a 120 volt terminal, not 240, which is capable of giving you 1.56 kilowatts worth of PV power during daytime, of course, not night. And it also has a short-term inrush capacity of 2.5 kilowatts for 3 seconds. Okay, so even without any sort of battery or hybrid option, and this is not on the same terminals with which the inverter is connected to the AC panel board. It's a separate terminal, which is called the PV point. Now, I did have a question the other day as to whether you can use the PV point when you are connected to the grid, as in without an outage. That is an option in the European model. It is not an option for us here in Canada yet. Okay, now this is to kind of give you an idea of how it actually works. So you can see that backup power connection supplied in case of grid outage, which would be your PV point, etc. Then you've got the automatic switchover in case of a grid outage, and you are able to supply up to 1.56 kilowatts worth of single phase 120 volt, not 240 volt supply. Okay, so you don't need battery. batteries or storage to be able to use the PV point. The only thing is the PV point isn't available during nighttime because you got no sun, and it's also not operable when the grid is connected to the inverter, as in you don't have an outage. You cannot use the PV point if you do not have an outage. So again, 1.56 is not an awful lot of power, but it's still a pretty slick option, because you don't need storage for this. Now, in terms of flexibility, the flexibility is basically because the operating range on the DC side of the business for this inverter on the string mounted side is from 65 to 600 volts. But as I mentioned earlier, just because you do have the option of working at 65 volts does not mean you should be working at 65 volts. Okay. The PV point is 1.56 kilowatts. It's not 3 kilowatts. Okay. Yeah, now this is a little bit more from the spec sheet. And so here you can see that we've got that wide voltage range from 65 to 600 volts that I told you about, which means that you can go down on the string length to strings of as low as 3 PV modules, but that's not always something that you should be aiming for. So unavoidable, yes, do it. Avoidable, definitely don't do it. Okay, and so you've got two MPP trackers. You've got the Primo Gen24 for the small capacities. The current capacity between the MPP trackers is not the same. Tracker 1 for the smaller inverters is about 2/3 the capacity of the inverter compared to Tracker 2. For the bigger ones that are 7.7 and 10, it's equal on both of them. And again, this is usable current. Your short circuit current can go much higher. So for the 22 amp usable current, the short circuit current capacity is 36.5 amps. For the 12 amps, it is 19. Okay, and then again, as before, the oversizing limit is 150% of the rated AC power. Now, in terms of the cooling technologies, some manufacturers offer you passive cooling. That is, they believe that the failure rate on the fan is high, so they don't want to throw in a fan there. That's passive cooling. You just have a very big heatsink. We do not believe in that because electronics do run hot, and the hotter you run the electronics, it could potentially affect the life of the device. So we always will choose to go with active cooling technology, which basically we are talking about here is a fan. Now, on the older model of inverters, you would have seen the heatsink is on the rear, the fans are on the sides, the intake is on either side, the exhaust is on the top. This is a little different because here, the heatsink is in the front, the electronics is behind the heatsink. On the older models, the electronics was in the front, the heatsink was behind it. And so the electronics is behind here, the heatsink is in the front, okay? And the fan goes over the heatsink here. So the intake is on the front, so you draw air in from the front and you vent it on the sides, that's right behind the cover. So the cover, the plastic cover actually works as a baffle plate or a deflector if you want, okay? This is just an animation of the same thing. So you've got the little black portion on the bottom, that's the connection area cover, okay? And the top is the heatsink itself. So the heatsink is aluminum, and the aluminum that is used for the heatsink is entirely recycled. There is absolutely no new aluminum that is being used here. Okay, now, so there's many different ways you can use the inverter, or this is what we call energy management. Now, energy management as such has not taken off a whole lot in North America, simply because smart grid compliant or ready devices are not available yet. I mean, they are, but it's not mainstream like it is in most of Europe, okay? So now the existing primos and the SIMOs have data managers, which are also capable of performing energy management if you know how to use it. And excuse me. And the Gen24 carries through with the same idea. The Gen24 is also capable of performing energy management. Now, what is energy management? Excuse me. That is entirely decided by what you stand to gain or lose if you were to sell back to hydro, use it yourself, do something else in the house, or store it. Now, all of this is decided by the price of energy. So in countries like in Europe, where the price of energy is very high compared to what we are used to here, and also the utility structure, rate structure there is designed to discourage you from selling to the utility. For us, it's not the same. We use net metering or FIT contracts in Ontario, where it's very lucrative to sell energy back to hydro. It's not always the case. Now, in Europe, hydro has absolutely zero interest in buying energy from you. They'd rather sell to you, which is why for them, it makes a lot of sense to invest in storage. And if you don't want to invest in storage because it's grossly expensive, then you throw into the picture energy management. Energy management is basically, if I'm overproducing, there's nobody at home, and hydro's paying me peanuts, then what I would do is I'd rather use that energy to operate different loads at home. That is energy management, because it's cheaper for you to use your own energy than to sell back to hydro at peanuts and buy it back from them when you need the energy later in the day. Okay, so a few good examples are basically hot water heaters, which we call the Ohm Pilot. So it's a little appliance, a relay-based device that goes between your hot water heater and the data manager and the old inverters, or the pilot in the new inverter. And you can basically program into the device through the data manager or the pilot settings that if I'm producing more than this much energy, and if you have a smart meter, you can game that into the system as well, then operate this load so that I'm using my energy there instead of selling it to hydro for nothing. That's the watt pilot. You can also use the ohm pilot, which is basically an EV charger. So the same concept holds here. If I'm producing more energy and dumping it on hydro for nothing, I'd rather use that to charge my EV. Or you could use your HVAC unit or your washer dryer. Now, it's just that you need to have an interfacing device between them. So most your appliances in Europe have that either inbuilt or you can buy it off the shelf. It's not taken off yet here. But if you know what to do, you can basically kind of jerry-rig yourself, or you can pay somebody to put together something like that. It's really not that complex. So in terms of the energy management, that's what you could do. That is performed via the digital IOs. IOs are short for inputs and outputs. Outside of that, in terms of the communication features and options you've got, the same options with the data manager are carried through here. Okay, so it's very easy. You don't need to do anything. And like I mentioned before, the data manager in the past will either have to specify the inverter as a full or in advance to have it pre-built into it, or you could buy the inverter separately as a light, buy the data manager separately, and install it yourself. That is, the hassle doesn't exist anymore, simply because every inverter now would have the pilot, and every pilot is capable of doing all of those options which the data manager could do, in addition to all of the digital IOs, the communication. You can either have the wireless or the wired connection. And if you do go wireless, you got to remember it's 2.4 gigahertz frequency for the Wi-Fi, not 5. And if you will go wired, then you can either go via the Ethernet. You can also pull data off of the device via Modbus TCP RTU, or we've also got the APIs like before. There's also the push service as well. Okay, so as before, just to recap, you can buy the Gen24 and upgrade it. Or John, sorry, could you take over, please?
Yeah, sure. I can jump in, Harsha. Again, for those that attended the Tuesday session, I'll apologize because this is a bit of a repeat, but so why Fronius and why the Gen24 specifically? The Gen24 does have the ability to be upgraded to a hybrid inverter, as Harsha has talked about. Doesn't have to be done immediately, can be done anytime after the install. Just want to expand on something that Harsha said about our web shop or the UP.storage slide as it went by. Absolutely, it has not been launched in Canada as yet, but the ability to upgrade to a hybrid, we're working with our Austrian office on processing that upgrade software purchase, no different than a customer would purchase an extended warranty. And that's all handled through our customer service team. So more details to follow on that when we're ready to go on that front. But know this, the hardware in the Gen24 and the hardware in the Gen24 Plus that's being launched in November of this year, the Gen24 Plus being hybrid out of the box, the hardware in both is identical, difference being the software between the two. So coming back to the Gen24 as it is a grid tie inverter that again can be upgraded to a hybrid. So for a consumer that has no plans of battery storage, why pay a hybrid price today? It simply makes no sense. As Harsha reviewed, it is operable down to 40 degrees below, which is obviously ideal for pockets of Canada. And just carrying on with the why Fronius and why Gen24. So I want to point out that while the Gen24 is new technology to Canada, it is not new technology to Fronius. We've sold already over 500,000 of these inverters worldwide, mostly in Europe, Latin America, and some other countries as well. So it is proven technology, and now it's the time for its launch in both Canada and the US. It is geared to the residential market, being a single phase unit up to 10 kilowatts. We are working, as I said earlier, on a 3-phase solution for the existing SIMO inverters that we have. It's a product called the Verto. We do not have a launch date yet in Canada for the Verto, but yeah, you can find it online for sure, up to 33 kilowatt, 4 MPP trackers, and again, 3-phase. So we're quite excited as we work towards introducing that to North America in a reasonable timeline. And again, now speaking about the company more so than the product itself. So Fronius has been in the Canadian solar market since solar started in Canada, and we haven't gone anywhere. Others have been and are no longer. We've been here since the earliest days and have no plans of going anywhere. But beyond that, I really like our value proposition in Canada, and beyond the product and beyond the technology in a product and track record and all the rest of it, I think we really have to concentrate on the Fronius infrastructure in Canada. And here I am referring to a number of things, but first and foremost, our technical team, both Harsha and Ricky, are second to none. They're in Canada. They know the Canadian market. They know the Canadian code. They certainly know our products. And as importantly, they know you, the Canadian installer. So I'm thrilled that that we have that because again, when I look at the competitive landscape, so many of our competitors offer technical support, but is it here? Do they know you? And do they know the Canadian market? We have inventory in Mississauga, as the timing of this webinar is ideal because if you check on LinkedIn and look at the Fronius Canada LinkedIn page, you will see a splash that was posted today as our very first order of Gen 24s hit our Mississauga warehouse today. So there's a picture on LinkedIn. We're all wearing the Gen 24 hat, so nobody's allowed to rush to my Outlook inbox and ask for hats. But if you come to one of our roadshows, there'll be a good chance of securing one there. So we have technical support, we have local inventory, we have our finance team here, we have an experienced customer service team that have been working with so many of you for so long. And as mentioned, we've been around since the earliest days of solar in Canada. That's our presentation. I put my contact information up there as the last slide. I'd like to thank Harsha for being tip of the spear on this presentation. He was doing all the heavy lifting on this one. But if you have any questions or any follow-up items that you would like to know more about the Gen 24 or anything else that was discussed today, please don't hesitate to reach out, either my email or the cell phone that's on the screen, and we'll get back to you as quickly as possible. So as we started, and before I hand it back to Tatum, I truly appreciate the time that you've given Fronius today. We are fired up about the Gen 24 launch. Because we were doing the math and it has been 10 plus years since we launched new technology to Canada. We've been running with the Primos and Simos, two great products, but we've been running with those for 10 solid years without introducing anything new. The Gen 24 is just the start of the good noise that we've got coming to the North American market. Gen 24 now, Gen 24 Plus in November. Verto scheduled for 2025. We've got other things that are in the pipe, including the e-mobility solution. So between now and the end of this year, 2025, 2026, 2027, you're going to see a constant drip of new products coming from Fronius. And after being somewhat dry for the last 10 years on new product launches, we're thrilled to be in the position that we are. So with that, Tatum, I'll hand it back to you. And again, thank you all for your time.
Thanks so much, John and Harsha, for presenting today. New exciting things coming down the pipe as well. I don't see any Q&A questions, so I'll just give it maybe another second or two if anybody else wants to type those in. I believe Harsha was answering those in the background. If you want to read, you should be able to see those questions there. Oh, we've had one come through. JP, I believe this is in response to maybe a question he already asked. He said, so I also see no added terminals for external SPD, and I'm just trying to see what question that was referring to. I think that was related to integrated surge protection, I believe. Does that make sense?
Harsha.
Oh, yes,
Harsha.
sorry. I'm sorry. I forgot I'm not muted anymore. My apologies. Yeah. I just kept typing away. Oh, so there is a small attachment that can be purchased as an add-on for incorporating search protection.
Okay. Perfect.
I'm sorry, that was a major, brain
That's
fart.
okay. No worries. If there are no more questions, thank you again for joining, and thank you everyone who took the time today to join this live webinar. As mentioned at the beginning of the call, this webinar recording will be sent out by the end of the week to everyone who attended. And you can reach out to John if you have any further questions. Thank you so much, you guys.
Thanks, everybody.
Have a great rest
Thank
of your
you.
day.
Thanks for having us. Thanks.
Bye.
Bye-bye.